So the factory was in Timisoara. So where are we now? Romania, right?
Romania. Okay. So just getting there, I spent 2 days there, so I just went to the factory and said, I'm not leaving here until you have 6 prototypes for me here that I can bring with me. So I sat at the factory, and it's a good experience. I think anybody who's passionate about their products or, want to put some pressure on their suppliers should try that.
Go and sit in the factory and just wait until they come out with a unit.
Because they're not very comfortable having somebody else there. So, I mean, I think it does speed up things when you do something like that, for sure. To make matters worse, I came down with a fever as well when I was here. So I wasn't at my best, and I got some dodgy Romanian
food or whatever
pills to take my fever down. So finally, but anyway, I get the prototypes. I get on a plane at Timisoara this time. Timisoara, Vienna, London, Kuala Lumpur, Sydney, and bang,
Melbourne.
Here I am, Melbourne. Quite confused. The whole trip lasts a week, so I was 2 days in Romania. So from when I started, so I've seeing I was semi-sick. I'd already lost sort of kind of track what day it is, but I think I arrived on a Wednesday morning in Melbourne.
And then more or less like 1 or 2 days in Melbourne max.
No, the next day I had to leave. So there were two meetings. There was a meeting with their technical staff, where I sort of put up all the prototypes for them and sort of...
demoed it, or what did you do?
Well, demoed it. We had a long discussion, explained the importance of timelines, this, that, and the other. And they actually unpacked one and had a look at it and inserted a SIM into it and connected a phone and just checked and see, it kind of works. And the funny thing, what happened during this meeting, because he'd used his SIM card from his ordinary cell phone, and during the meeting, the phone actually rang. So the thing worked.
The prototype
worked, and he answered phone, and everything worked. After that, there was no more discussion. So that was a magic moment in.
So bottom line, right? When you're a product manager, this is cool stuff.
Yes, it's kind of. They were super happy. The tech guys. It actually does work. In the meeting, it was proven without.
And was this the very, very first batch that you delivered?
Very first batch. No, they've never tried it before, and we hadn't actually 100% tried the meat either. I mean, there were stuff in the lab that were.
Yeah, and what is this product, by the way?
It was called a fixed wireless terminal. It's really to substitute a home broadband and phone connection. It was something that in the early 2000s, a lot of telcos were looking to replace cable out in rural areas and have such a box. And it's becoming more of a phenomenon today as well. But today you're delivering even higher broadband services, but also TV service that way. So it's.
So what is it? Essentially, it's a box with a SIM card, and when you connect to this box, all of a sudden you can have like several people using it as Wi-Fi.
Yes,
or something like this.
It has Wi-Fi or Ethernet.
But SIM-based Wi-Fi, if you like.
Yeah.
3G, 4G at this time.
3G.
3G.
So you have to remember at this time 3G was pretty new. This is before.
This is even new 3G.
Yeah.
Oh my God.
3G was pretty new. There was no smartphones. There was no iPhone. So
this is
Yes.
No smartphone, no iPhone times.
Yes. So you have to remember the context of when this. So fantastic meeting. The thing works. I'm happy. The customer's happy. Next meeting was just a yelling meeting where one of the 3 amigos sat for an hour and just yelled and told how worthless we were.
Part of negotiation.
Probably. I was young and inexperienced, and the local Ericsson team said that was a good meeting, and I was like, okay. But I guess it's something that you've learned because the meeting lasted for a long time. If it's a short meeting and somebody else at you're probably never coming back. I mean...
but a long meeting and they yell, they kind of want to have you to stick around.
Yes, something like that. So that was interesting. And So that was my Wednesday, 2 meetings. Thursday morning, jump on a plane and get back home.
Yeah.
So
let's get back to a little bit to Australia later and all that and what that experience was all about. But let's start. Daniel Lewis, who is Daniel Lewis? What's your journey into this space?
It's a good question. Who am I? Let's start with some defining moments in my life that have taken me to where I am today. I mean, one of the big things in my life was, I'm not sure if it was Christmas or if it was a birthday or something, I got a Commodore 64 computer.
Ooh.
I mean, this is, for anybody who's likes technology or that was, wow. I can't remember if I was 9 or 10 years old. I mean, that was a defining moment. You got this thing that you connected to the TV. You could play games on it, which was, of course, super fun. Computer games, even though that were,
basic stuff, but
very basic stuff compared to today. But it was amazing. But you could also write programs on it. You could do stuff on your own on it, which was like.
Were you programming when you were a kid, or were you more of a gamer? Or both?
I did I was more of a gamer than a programmer, but I did a bit of both to basic understand. But I understood that computers were magic. These were really something that you could do things with and take you places. So that was a very defining moment for me. So that started my really
tech interest even.
Yes, absolutely. That started my tech interest. Other defining moments, I lost my dad when I was 19. He died of cancer. So, I mean, that's a very defining moment in my life. I had actually just started my degree in engineering at KTH here, Royal Institute of Technology in Stockholm. And it was tough times, and I actually dropped out because I couldn't find myself to focus on studying during that period. So what I actually ended up doing was joining Ericsson because I've been
quite young, yeah.
Yeah, so I was
like 19, 20 even, 21 maybe.
21. Yeah. So the studying part didn't fall out very well. Joined Ericsson, and the reason why I joined Ericsson, my father had worked at Ericsson, and I'd been an intern at different parts of Ericsson during summer, so I knew some
the company a little bit, and you liked the company.
Yeah, and some people, and you call people, and say, hey, can I, continue here? Yeah. So I started that and had a very good school there. Spent actually 19 years within Ericsson doing different things, a long journey there.
I need to ask you, you told me this privately, but I think it's a cool story. Didn't you one time, and I think this is quite early in your career at Ericsson, go out to fix the PBX at Peter Wallenberg's mansion, like the CEO of... or the chairman of SEB at this point in time? This is ages back.
Yeah, so Peter Wallenberg, the Wallenbergs are the family that influential industrialists and banking here in Sweden, and they own and control a large part of Ericsson. So of course they had
good Ericsson products at home.
Well, a PBX is not something a normal person would have at home.
What is a PBX, or what was a PBX?
Exactly. So now anybody who is younger than 40 years old probably doesn't know even what a PBX is. So PBX stands for Private Branch Exchange. So it's a branch telephony system for small, medium, or large companies.
So it's a Vexel. It's a small.
Yes.
What do you call it in English?
Switch.
It's like a company switch, typically, right?
Yes, and he had one at home at his residence, and
so this is not a B2C consumer product. This is a B2B product.
Absolutely not. It's a B2B product, very much so. So, and how he got it and installed, don't ask. It probably came out the factory and into his house. He had these were digital phones. They weren't analog, so they had extra information and function so that, if a call came through, it would ring on all the phones in the house or whatever if it was important, etc. You could, so several people could join the call, but in different rooms.
So we're talking 80s, 90s or something like that. I don't know.
It's
90s,
late 90s. Anyway, something wrong with it. Peter Wallenberg called somebody at Ericsson, and it trickles down. So I happen to be left in the office. Some boss comes in and says, "Hey, we have a problem. Peter Wallenberg's switch doesn't work." And you go, "Can somebody go?" And I said, "Yeah, why not? Okay, I'll go. I'm here. I don't have anything to do at home right now, so Thursday evening or whatever it was." Yeah, so I grab a cab, get out to his residence, which is outside town, pretty far out, and get let in, through the gates and everything. This is not your average residence. I mean, this is a pretty important guy, one of the most important industrial people in Sweden, and he can't phone. I mean, you have to realize, of course, he had a mobile phone, but I mean, people called fixed phones in these days, and he couldn't call out, and people couldn't call in, so that was a problem.
Had to be fixed.
So pretty big house. More phones in the house than
the normal house.
Than the normal house. I'd say even a small office maybe wouldn't have as many phones as he'd had all around the house.
It was like a full media setup, I guess.
He had the works. In the basement where the exchange was installed. He had all kinds of satellite racks, and he had direct feeds out of Reuters and things like that. Of course, I mean,
well, why not? He should have.
Yeah, I mean, important business guy. Today we have the internet, so it's pretty easy. But I mean, in these days, this is what you had. So I mean, he had a setup, that's for sure.
He had a good pad.
So it was interesting, and
could you fix it?
Semi-fix it. So it kind of did some bypass, but there were several things that needed replacing because it was old, and But got it working. So he at least could phone. Yeah, and then while waiting for the cab, had to sit down in his couch and had a bit of a chat with Peter Wallenberg, and he kind of asked me a few questions, what I did and so forth, and I said, yeah, well, I do this at Ericsson, private branch exchanges, and he asked me, do you travel in that? Not so much. I hadn't started traveling at Ericsson at that point, and then but I said I'm half English, so I spent time in UK, and he said, yeah, I spent a lot of time, because when he was young, he didn't join the bank as the family should, so he became an industrialist. So he actually went to Northern England and dealt with machinery and shipping and stuff there. So I mean,
he has a cool background.
Yeah. So he's a proper industrialist. So he's not a accounting guy. So he's a business guy and industrialist. So it was interesting. It was one of those moments here, 21, 22 years old. You meet somebody who's super influential
in Sweden, like one of the main guys.
Yeah.
At this time.
Yeah. So that's, I mean, that was also a aha moment. You go like, wow, this is very different to what being around the office and the important guys there. This was sort of off the charts to that, But he was very laid back.
Cool. And back to Ericsson, so what things have you been sort of working on, or what's been your sort of field in Ericsson?
So it's
or defining moments, even, I guess.
So we'll get back to that. So I mean, in the late 90s, I started with private branch exchange. There were,
this is wireline. We talk about, we talk wireline versus wireless in Ericsson right now. Right?
Yes. So we're still pretty much wireline, but the trend at the end of the 90s, going into the 2000s, there was something called voice over IP that was starting to emerge. I mean, Cisco started to emerge as a big player with enterprise data. You started to get packet data networks going.
The Cisco switches, the core switches, blah, blah, blah.
Exactly. And that was starting to eat into telephony, because you could, instead of a circuit switch telephony, you started a packet switch telephony. And Ericsson was a little late to the game. So the next defining moment, Ericsson made a acquisition in Silicon Valley of a small company, fairly small company. I think it was around $150 million at that time, called TouchWave. And I joined sort of a team here in Sweden that was going to work with this new this voice over IP product and bring it into Ericsson. And so I started going to Silicon Valley, and that was a defining moment for me in my career at Ericsson also. To
get the vibe early. You got the vibe early.
Yeah, it was so different. I remember first time coming in, they were based in, I think it was Mountain View they were originally based in, and come in to this office, and it's only concrete floors. It's cables all over the floor. There's just these cubicle walls set up here and there sporadically, and it's like, I was like, is this an office? It was nothing like in Sweden's everything's organized. Everybody had a room and all these kinds of things, and it was like, where am I? What is this? So
what is it like more hardcore factory garage tech? Use tech focus.
Yes.
Tech.
There were just people. People were there. They were sitting coding. That's what they did. And it's like, it was
different vibe.
It was very different. But the one thing that they did have, this is a Silicon Valley thing that I discovered also later, that any company really you go to. I don't know if that could have changed. They have a kitchen area, and it's loaded with soda and snacks and stuff just to keep people happy.
And keep working.
Keep working. There's always something to eat, and in Sweden we have the coffee machine, which is like the holy grail. This seems to be like the Silicon Valley,
the snack area.
The snacks with the sodas and so forth. So, but the experience of being there, it was like, it wasn't important, what it looked like. It wasn't important. It was, it was sitting there coding
But it was tech code is the holy grail.
Yes, it was. People sat there and worked, and we need to get this working. And it was an interesting and learning experience.
And when you did this project, is Ericsson still a wireline company, or has it started to emerge as a wireless? When is the defining moment for Ericsson here to become a wireless company?
I think that had already happened, but we belong to another part of Ericsson that was still the wireline. So Ericsson hadn't given up on that yet. So we were still in the wireline space. But after this period with this product and I moved into wireless. That was sort of my next step within Ericsson, because the wireline side was going downhill more or less. I mean,
you see as an industry, as a company, where this was where the trajectory was for?
Yeah, it was starting to go downhill. I mean, people adopting cellular at a very. I mean, it started to really boom among consumers, that people started buying phones. Because when I started Ericsson, mid 90s. I don't know how many had their own mobile phone. That wasn't that common, but it gradually started growing, and everybody started having a phone, and I saw that this is the future. I mean, it's going to be wireless. That is definitely the future. Mm. So that's how I kind of moved into wireless, and then started looking at. So that's how my first product, moving into product management, was looking at, well, how do we replace wireless or wires with something wireless that gives you that same functionality. And initially it was,
voice over IP.
No.
Oh.
Not really. But you cut the cable, you put a box in instead that uses the wireless network, but you stick your phone and your broadband connection into that, rather than you have somebody that's pulled out cable to your house or whatever. So that was my next journey in there, and ever since it has been sort of on the wireless path with the different technology. So it started with 3G, and now we're at 5G.
And then some point here, I think you went into Ericsson Enterprise, the products you work with that belong to one function within Ericsson, which is more enterprise product, or
that was the PBX side.
That's the PBX side.
That's where I started.
Okay. So and when is the transition here to Sierra? Because what year is that?
What year is it? I usually think it wasn't long ago. I haven't been at Sierra that long, but it's actually 7 years now. So it's so in 2013 I joined Sierra Wireless, and the reason for that. So after some of my fixed wireless endeavors, I started sort of going more low level into that, and we were doing something called wireless modules. So this is the precursor, I would say, to the IoT and M2M world that we have today. It was building, in that case, it was broadband modules to integrate into laptops and other devices to have a cellular connection in them.
So this is like, if we go back a couple of years, some people remember it, you were able to stick a SIM card into your PC, stuff like this.
Absolutely.
And your technology was essentially the module that was in your Toshiba or in your Dell computer.
Yes. So
you sold to Dell and to Toshibas and the likes.
Yes.
As an example, yeah.
As an example. So it's an alternative. It's not a mobile phone. It's only the data part to enable a broadband connection in any device. So Ericsson did that for a while. You have to remember, this also started pre-iPhone.
Yeah, this is pre-iPhone.
When this all started up. But
pre-iPad.
Pre-iPad. So, and at the time, Intel was pushing something. So we talked a lot to Intel. Intel was pushing something they called a MID, mobile internet device. And what do you know, I think, 2010, 2011, what came out? Apple brought out the iPad, which was literally MID, mobile internet device, but done
their way.
I mean, but it had cellular connectivity. So it was sort of, all the ideas have existed prior to that, but I think Apple sort of nailed it with an iPad with what we were doing. So that was one of the sort of type of devices. And then we started looking at how do we go broader with this? How do we go outside the space of computing and that? And
SIM cards everywhere. Or now so this is sort of ramping up to Ericsson's call connecting 50 billion connected devices or something like that. So this is a couple of years earlier, but you were in the position. I think we talked about this even back then, how this was emerging in this direction.
Yeah. So Ericsson coined. They had a vision that by 2020 there would be 50 billion connected devices.
How did we go? Do you know the stats?
I think they talk about 30 billion in there, but then you can you can discuss whether they are cellular or other technology. Yeah. But there's a lot of connected devices, but there's still a lot that is not connected. So I mean, we started looking at sort of the broader scope, but then Ericsson decided, for different reasons, that Ericsson is a network company, focus on the network rather than the device side, and that's when I decided, well.
You like that style?
I like the devices. I like the stuff that goes into people's hands or into somewhere where you can touch. The network is, it's more abstract.
More back end.
It's more abstract, and if you work with a network, you don't really work with the whole network. You work with a tiny piece of it. Whereas a end devices, it's something that you can touch and hold and, more relate to.
So, and then Sierra Wireless, which, I mean, like maybe not everyone in Sweden has such, I mean, like Ericsson is a household name in Sweden. In Sierra Wireless, it's a Canadian company, right? So
yeah.
So let's do the company and the story at Sierra.
Yeah. So okay, Sierra Wireless. So I knew Sierra because if you're in the industry, you know who's in the industries. But
so they were your competitors, in some ways.
Kind of, yeah. So they definitely a competitor. I mean,
to Ericsson at that point in time.
Yeah. So Sierra Wireless is a pretty old company. If you look at the industry they're in, they're 27 years old, and
with wireless
and focused on mobile data and enabling mobile data into devices. They started also with computers and gateways and cater particularly for type of rugged type of installations and that. So small company that's grown and grown and grown. So when I joined Sierra, there were around 650 people. So fairly known in the industry and fairly, pretty global presence in all the continents. And while I've been there, Sierra's been on a journey as well, from going from a hardware company moving into a more of a service company and building a more complete stack in the IoT space. So let's talk about that. So let's talk about Sierra. But what does that mean to be? What does that concretely mean? Going from hardware to what does that mean for Sierra? Yeah. So for Sierra, that has meant. So I mean, if you look at it, so Sierra had a broader view of the market than Ericsson. They'd started looking earlier at not only enabling PCs and broadband types of devices. So they had other types of devices that didn't need that amount of data. So they had made acquisitions and start forming their company. So there you talk about very low bandwidth applications, but still needed to be connected, like, I don't know, for temperature measurements or whatever. You have
so the spectrum was wireless connectivity.
Yes.
End to end. To some degree, or not end to end?
Not end to end, but selling hardware into those spaces.
But I don't mean end to end, but there are many types of connectivity use cases, and the full spectrum of connectivity use cases, where sort of 5G might be on the higher spectrum of what you really need into connectivity, and then you can go down to.
Yeah. Correct. So Sierra had a much broader portfolio to address a larger space of the market.
The connectivity.
Yes.
Use cases.
Of enabling the connectivity. Yes. Whereas Ericsson only focused on a much smaller piece of it. And how that evolved and the journey that Sierra's been on is well, if you sell hardware, you just kind of sell it once. Somebody does an integration product and then they buy hardware, and that happens typically mostly on a project basis. So
like you are there to compete to get your module into whatever they're building, and then you're going to build, and then you're going to sell that, you're going to produce and supply that module as long as that module and that life cycle of that product lives. Is that fair?
Well, in general, yes, but I mean, we don't make custom modules. It's generic modules, so there's several. There'll be many customers, but
but you're trying to get them to buy this particular module in our assortment, in order to solve the connectivity for this piece of hardware or something like this.
Yeah, correct. And well, once you've done the sale, I mean, then that's kind of finished with your relationship. We're
a supply chain relationship going on.
Yeah, maybe, or they just buy in one shot, and then maybe in 5 years they'll come back. We're going to make a new product, an upgraded one, and you don't have so much of of a relationship there in between. So it goes kind of quiet, or you just have a supply relationship, as you say. Mm-hmm. So what Sierra has done is if you look at connectivity, what you need, You need the hardware to enable that, but then, the magic is the SIM card, the service, right? But if you look at traditional carriers around the world, they cater. Who do they cater for? They cater for consumers. They cater for mobile phones. That's what their business is centered around, right? So, but if you're connecting a machine, you have a totally different point of view. What is important? I mean, typically you don't need speech. That's unimportant. But what you do want is kind of reliability. What happens if the network goes down? I still need my machine to be able to communicate. So how do I do that? So it's more important. I want some sort of failover between networks and that. I mean, if you have a SIM from your provider here is Telia or Telenor, if that goes dead, if their network goes down, your phone is dead. But if you have a piece of machine, that might not be an option, right? You want it to fail over to whoever there's a connection to. So Sierra looked at it, said there's an opportunity here that in this space, there's a need for a different type of connectivity, a connectivity for things.
And even a different type of carrier or operator type contract.
Yes, because the business model is different. I mean, a traditional carrier, what you send, you've got this bundle. It's so.
Yeah.
Sorry. Okay. So the contract says you buy a bundle and that's it. But that's not maybe how the machine you want to do the business. You might want to buy the data for the whole life cycle of it up front. You might. There are a number of different ways when you connect things how you would like it to be rather than
what we're used to as
a consumer with a phone.
Thanks.
So Sierra did some acquisitions, what we call MVNOs, which are mobile virtual operators. So what that means is that they don't have their own radio network, but they have their own core network and can issue SIMs and so forth. So they have contracts and deals in place with the traditional carriers to use their front end, the radio network, but in the back end, they take care of the data in their own network. So Sierra's done a number of those acquisitions and become a global mobile virtual network operator for IoT.
All right, so now we're moving into what is product even? So so clearly we're going to get back to IoT and all that, but I think as a theme in between here is a little bit like there is a shift now of the physical product and even the physical component as a product that you've been experiencing to basically now, we need to be an operator, we want recurring services and stuff like that. So, but before we go let's start with the basics. What is a good product, or how do we look at good products? What's your experiences thinking about product, and how has that evolved?
Yeah, so I mean, this is again, being passionate about products and that it's fit for purpose, because I think we tend to build things that are good at many things, but not very good at something specific. So you end up, always have to compromise. So you can't be everything for everybody with a product. And I've always, something that I think the school at Ericsson and with product management and that I learned a lot of good lessons there. And what's important to have is the product view. What should we be doing? What should we say yes to? What should we say no to? Managing cost. I mean, because you get carried away, especially when you're young and it's not your money. And this is also tying back to the Silicon Valley view that, you have to have an idea where you're going, and you have to say no to other things in order to be successful and to get the product right and get it out.
And I think this this understanding of what is your core value proposition, or what is it that you're trying to achieve. I think moving into the data and AI space, like sometimes it can feel, this is my personal view, that the hype or the tech almost interferes with, what are we trying to build here? We need to have big data, or we need to have IoT, we need to have 5G. Actually, what's the use case and what's the product's going to do? I mean, and now we're using a broader term, like it could be a service, of course, like this. But having this product thinking in terms of what's the purpose of what the use case that you're trying to solve? I resonate a lot with that.
Yes, and I think too many people just go, it's like the internet was new. I have to be on the internet, but why? What is it that you want to do? I don't know, but I have to be there. It's like, I need 5G. Why do you need 5G? I don't know. It's new, and I need to be future-proof. And it's like, but you have to boil down to use cases. I think is a very good way of looking at products and services. It's what are we trying to achieve here? And try to set boundaries of what we're doing, and not it's like, hey, let's build a module that does everything. Let's make it do all radio technologies, but then it won't do any of them really well, and who are you addressing? So I mean,
but I think this is a lesson really, truly, strongly learned if you work in a company like Ericsson, who is maybe some of the best in the world around product lifecycle management. They are really good at this.
Yes.
And they have a really strong process for trying to understand even how new releases should have different features, like a new radio base station we talked about in 4G, I remember, and used to prioritize where to take that, the next release. And I think the software companies as well, they figure this out. But I think this fundamental product thinking truly applies to a lot of stuff we are trying to do now in society. If I'm in the public sector trying to fix my some administrative processes, or if I'm in at Scania, or I'm trying to fix some workflows or something like that, to have that very concrete idea, what are you trying to fix? I don't know, and not get, and really nail that down. To me, that is a lot to be learned from the product companies, that you really need to be good at this, even when we do data and AI and these kind of stuff.
Yeah, I think you're absolutely right, Henrik, because you so easily get lost, and I think public sector is especially lost because, again, it's somebody else's money you spend, so you can go and do whatever, and you go and do things broadly, and things never come about. And I think Ericsson had a large project. I don't know if it was late 80s or beginning of 90s or whatever, where they tried we're going to do the final solution of a switch, and they spent years and millions, and it never amounted to anything. And I think after that, I think that's how Ericsson learned, okay, we need to focus on products and what they do, and have a proper education program around people who are responsible for our products, and learn to prioritize and focus on the product and how we build products, so that it's a venture cap model where you work out the numbers, and what are you going to build, and what. Yeah,
well, let's talk about a common story we have at Ericsson, where I was a consultant, and you actually been to a student to one of my classes.
Yes,
which is funny, right?
Yeah, that's
and it's quite interesting. I couldn't teach you anything in one way, but what really impressed me with Ericsson, and I think this tells you something about how to go about this, is that. Well, you tell the story, but it was this fundamental understanding: how do we put an industrialized understanding for product lifecycle management in place at Ericsson, and how do we get all the different parts of the whole big machinery of Ericsson to understand their part and their story and their contribution as a global team, as supply, pricing, R&D, how they all fit into this puzzle to create great products. So tell that story. I think that's a lot to learn around. If you want to industrialize anything, you kind of need to do something like that to set the standards of a company.
Yeah, and I think the governance around it also, like with very clear milestones and steering groups that is venture cap based, that you look at the numbers and say, it's a very good model, and I think Ericsson has mastered that very well.
I mean, like, and I've been, me as a consultant working with you has taught me that, and I've been using that ever since. And now we talk about lean startup. Eric Rice is the grandfather of the lean startup movement and all that. But Ericsson had that perfected, way before, because I have the proof, because I made the curricula around this. And it wasn't me who made it, but the whole idea what we did was that we took Ericsson's best of the best. Like I remember it vividly. I had a sponsor in Eric Bertels. If you remember him, he was heading up the product lifecycle management process.
Yes.
So his job was basically how do we get Ericsson to work as a machinery in a lean startup venture capital way. So what they did brilliantly was to understand the fundamental phases of venture capitalist. What do you do in the idea phase? What do you do in stage one capital? And then basically understood how do we weed out good and bad things to we basically decide, clarify what we need to do, and then build it. And the whole idea fits really well with the new concept of lean startup, and we say, we need to fail fast. Because the whole idea with the Ericsson model that we worked on, and this is way before this is in any, this was not in any papers, this was not in any books, but with the venture capitalist view on this, it meant we focused the whole of Ericsson to weed out with the least amount of effort the bad ideas. So basically, you don't go into real heavy stuff until you know what you're doing. Yeah. Super brilliant.
Yeah, correct. But I think, Ericsson being a big company, it's impressive that they do that, but it's hard because it's such a big organization. There's so many parts of a huge company that needs to fit into that model. The one thing I can say in hindsight that
could have been better,
could have been better is that because all my projects, so I've been shut down 3 times at Ericsson with things I've done. So starting with the Silicon Valley experience and that acquisition, eventually that went away, that got shut down, and then the modules also got shut down. So and I've worked on other
strategic direction goes left.
Yeah. Or you could argue that everything starts small. Things don't happen overnight. All companies started off small. No company started with a dominant market position or owning the market or it started in small steps. And I think that one of the things that I have a hard time with is that you need some perseverance and a longer term thinking that, it's not going to take off, the first, second, third, or fourth quarter. We're talking years here instead, that you have to have a bit of a longer horizon until things happen. That doesn't necessarily say that you're going to throw lots of money and spend things forever, which, with a venture capital model you won't. But, we have to get away from more of this short-sightedness. And I think that is extra challenging within a big company, because if something doesn't fly there, we're off to the next thing. We'll try something else. And that makes it hard starting new things within a company. I think it's easier. That's why startups can come along and be successful and grow into huge companies, because it's easier there.
But here, let's finish the product and what is a good product and this first, because then we can after that move into the theme around KPIs, budgeting, quarterly time steering. How does that really work in terms of innovation and product? But to summarize, a couple of things here, which is sort of takeaways also for the data and AI space. An industrialized approach. We are not talking now that, it's more about the mindset and how we are putting frameworks in place for the whole company organization to know their part. And I think that way of that Ericsson did is completely applicable to data and AI. When you have a data engineer, you have a data scientist, you have a service designer, and these guys need to work in unison in order to go from idea to production, right?
Yeah.
So I think the main takeaway of some of the, what is making Ericsson succeed is this way, this understanding for how to industrialize things. And basically, if we now concretely talk to the people who hasn't worked with Ericsson, what does that really mean? Well, it means that you don't go in generic trainings. It means Ericsson takes the best of the best concepts and then figures out what's the Ericsson way we're doing this. And then basically when we talk about the process or product lifecycle management or supply or pricing, we are taking it to world class the way Ericsson does it. And I'm super impressed with that whole stamina to then say, like, okay, all product owners and product managers in Ericsson, they kind of need to have, they're free to do whatever they want, but they kind of need to know how the machinery works.
Yes.
And they get taught how the machinery works. And who does that? No one does this.
No, it's multidisciplinary, as you say. So everybody has to fit into this model, and it has a set of rules that you have to go. But the idea could be anything.
So the whole to unleash innovation that fastly scales to product innovation and scales globally is like, we have this framework, we have this machinery, it works like this. And I teach you now the machinery, so when you get your job, and you can go crazy, but know how the machinery works and you will succeed. So I think Ericsson mastered this way of product thinking in some ways. And that's I think this is part of their success.
Yeah, I mean they keep churning out new products and services that are top notch in their industry. So for sure, but I think when they get out of their comfort zone, doing something that they maybe that becomes harder.
So the problem. Okay, so what's the downside of the way of working? So the way of working, the frameworks, they are really geared to a certain type of core positioning.
Yes.
Right? What Ericsson has always been good at, working towards the operators.
Yes.
So all of a sudden, when you move innovation full on, away from your sort of core domain expertise, not as sharp, maybe.
No,
or it's tricky to make it fit.
Yeah, I think it's more of a fit, and that people think that they're outside their comfort zone, and also based on strategic direction, right or wrong. I mean, somebody has to run the company and decide where we're going, and if it doesn't. But that's also part of just like a product. We have to know what we say yes to and what we say no to. And no company has unlimited resources. So if it doesn't fit where we're going, then maybe it's more right to say no. And the same is whatever service or the thing that you are conjuring up, you should fit for purpose is something that you should do. Does it solve the problem that you're looking for? I mean, it does. You don't need 10. If you only need one lever, just make one lever, not 10.
So, and this also becomes this whole idea: lead with the business problem, the use case, and don't lead with tech. Because when you lead with tech, someone who's going to sell you tech, or when you're going to install the tech guys will talk about, we could have this scenario, and we could have this scenario, and we could have this scenario, and you end up building this huge gizmo.
Yes.
When you really only needed one lever, and I think and the cost, everything, and this time, so stay the course, keep focused, understand what you're trying to build. I guess.
Yes.
That sums up that product.
Yeah. I mean, AI is supposed to help you, right? You want an answer to a specific problem. You don't want to know 10 other things, so don't lose sight of what you're trying to solve. Then you're usually, I guess you're more than 80% right then.
Yeah, and the point is then, for smaller amount of money and effort, you get something that works, that does the purpose, and then maybe you can grow from that. You can grow the features from that.
Yes.
Okay, but let's finish the product theme. But I want to do this now, if it's okay. We need to talk about the theme around innovation versus the quarterly budgeting setups and all that kind of stuff. But before we move there, I think there's more going into Sierra. I think before we talk about these types of technologies and services that also comes with IoT, let's really start breaking down, the introduction to IoT. How would we define it? What is the different things? So, because I think there is a lot of problems when we are using new words and we hype them up, and IoT becomes the new hyped word. But I mean, let's break this down and get a little bit nerdy a little bit. What is to you IoT, and what is the fundamental components of it and stuff like this?
Oh, yeah. So, I mean, IoT, it used to be called, before that, it was called machine to machine, so M to M. It was machines talking to machines. So it's Internet of Things is just, I see it as machine to machine was, in its infancy. We're talking about maybe only a few things that we're talking to a few things. But when you talk about IoT, you're really talking about the, connect everything. Everything should be talking. Everything, exactly. So, and IoT is not one thing. It's a bunch of technologies, and there's many ways to do it. So I mean that's why you can't say it is this or it's that. And again, bringing back to the fit for purpose. I mean there's proprietary technologies that you can put up your own networks to do. There's LoRa, Sigfox. You can use traditional things like Wi-Fi, Bluetooth. There are others, short-range technologies like Zigbee. There's a whole bunch of things that fall under the IoT umbrella. And
but let's break it down, because I don't think people talk enough about the fundamental journey of something going from here to here. Like what are we talking about here? Let's be super concrete. So I'm in this piece here, machine to machine or whatever we want to connect. So concrete down on bits and bytes level. What do you need to do to get the sensor to work? Let's start here. What's the chip? What's the sense? How does wireless really work?
Yeah, well, how it works. Typically, you'll have some gizmo or something, that measures something. I mean, that's a typical,
All right, let's take a concrete example. You choose a use case or scenario, right?
I mean, you measure temperature.
All right, let's measure temperature.
Or humidity or whatever.
All right, so we have a temperature station in Arvidsjaur, and we don't want to go out to the station and read it anymore.
Yep.
So what's the fundamental technical journey we're talking about?
Yeah, so to get some efficiency, I mean, if you have something remote, and if it's to be read manually, so how many times a day can somebody read that manual? Well, if it's somebody local, maybe he can go there a bunch of times during the day, but, it depends. But maybe you want to have measurements of the temperature every hour. Okay, so then you have to send somebody there every hour, even during the night. Is that feasible? And the more remote it gets even, less feasible, and also more costly, of course, because you have to employ somebody that gets out there. So we'll look at a remote weather station. So ideally, you could have, short range sort of technologies that you would hook up to the sensor. And
what do we mean short range technologies?
Well, you could have a local Wi-Fi network, but seeing if you're out remote, that's probably not plausible. More likely you would have a cellular network, because cellular coverage, it's pretty good, but maybe not all encompassing. Worst case, if it's too remote, maybe you're talking satellite, but you'd need some sort of component that you stick to your sensor that can communicate with the other world.
So it starts with the sensor at the actual thing doing the reading of something.
Yes.
And this could be reading of temperature, it could be reading of anything.
Yeah. Anything.
And basically what the data point that you want to collect, that will tell you what type of sensor you need.
Yes.
And then from here, okay, the next step is to send it somewhere.
Yes, and you need to have a network which you send it over, and whether that you can build your own little network, or you could use something that exists, or satellite, whatever. And what seeing that I come from when I talk about wireless, I talk about cellular wireless, the standards that.
And what is the definition of cellular?
In my world, the cellular standards, it's the broad standards that we know as 2G, 3G, 4G, and 5G. It's the 3GPP partnership project that defines the cellular standards that move forward. There are other.
So this is a protocol that's been standardized within the actual telco, I guess, industry.
Yeah, and it's become. I mean, it wasn't all encompassing from beginning.
I remember the CDMAs, and when
yes.
this was a mess, right?
Yeah. So if you go back, there were and the cellular standards have they've gone through. There's a first generation, and the G stands for generation, by the way. So they were analog, and then the second generation that's known as 2G was digital. In terms of transmission, but there were different standards, that were diverse. But the standards body has
improved.
Well, people have come together and understood that in order for things to scale, to get the benefit of a massive scale, which mobile phones are. Everybody has to be on the same standard, because if I, even though I'm maybe 50 million here, compared to 7 billion, that's not a whole lot. If you're connecting everything, you want everybody to be more or less on the same standard.
When was the real shift? I mean, like in 3G, we had several versions, right?
Yes.
We had, CDMA, NTMMO in Japan.
Yes.
And we had LTE in not even LTE yet.
No. So LTE was more or less then everybody came on the whole.
LTE is when everybody came on board.
On the same train. So before there were different trains. So
LTE is really 4G train.
Yes. So that was the first.
The first true all-encompassing cellular protocol.
Yes. So everybody on the same train and in the whole world.
And if you can now compare LTE, that type, what are we talking about bandwidth here, and how can, now we're talking 5G soon. Let's talk about that later. But 4G is here. But of course, there are other protocols which are very much more low bandwidth, more like cheaper, or there are different protocols here fit for. You always say to me, horses for courses, or fit for purpose.
Yes. And you have to recognize that. So I mean, the mobile phone industry has been on a track, higher bandwidth. What is it that people in a phone consume? You have to understand that, of course, that is also fit for purpose. People watch videos, and
now we stream massive.
And the networks have been optimized, and the industry optimized for that. So there's been a bunch of protocols within the cellular standards that have shown up that are for low bandwidth applications. So there was kind of a split where they came out. So,
and which one are the major protocols in low bandwidth?
There are two. There's one called NB-IoT, which stands for narrowband IoT, which is very, very narrow. We're talking kilobits.
Then kilobits is like small packages.
Yeah, so that's thousands of bits of kilobits. So think of it, comparable to the speeds of 2G phone. I mean,
old school. But if it's needed, if
you just if you're doing temperature measurements, you
don't need more.
You don't need a whole lot. And there are certain traits with NB-IoT, and that we can go into that in just a bit. And then you have another technology called LT-CAT-M1. And that one has a bit more bandwidth. It's hundreds of kilobits, you would say, 300-400 kilobits maybe. Whereas NB-IoT is maybe 50 to 100 in that.
So what we're talking about here is to really understand your use case in terms of what's the size of the package that you're trying to send and to what frequency, stuff like this.
Yeah, so it's a fit for purpose, and another fit for purpose is the thing going to move about? Is your asset going to move, or
do you have an asset in a mine, like a caterpillar in a mine, or do you have something stationary?
Yeah, exactly. Okay. Or is it a logistic truck? Is it a truck that moves around the whole country? Then it needs mobility, because here's also a difference between MB-IoT and LT CAT-M, where CAT-M supports mobility, where MB-IoT doesn't. But they have different use cases. So this is what you need to do. You can't just say, "Oh, this is better than that and that." But it depends what you're doing, what the purpose you're doing.
So back to the product topic. So what is your IoT use case really all about? Are you Maersk driving shipping containers? Are you Scania working with trucks? Are you Tesla? Mm-hmm.
Yeah, exactly. What is it that you want to do? I mean, are you in a manufacturing plant? Or do you want to track where all your tools are? They probably don't move a lot. They're more or less a fixed asset. So, but want to know where they are for different reasons. So, I mean, this is where so those are two of those cellular technologies that have emerged, in the past 5 years that are specifically, I would say, for most of the for most of the IoT space, and they're known as LPWA, so low power, wide area technologies. And
if you define, what am I looking at when I'm looking at one of those gizmos? What is it that I'm actually looking at? Is like a card, or how does it look like?
These types of things are pretty small. Think of them, as maximum like 20 by 20 millimeters, and size. They're small. Looks like a system on a chip. They're totally encased.
You put it on the motherboard somewhere.
Yeah, you attach it to a PCB where you have your sensors and where you have a microcontroller or a CPU and some memory, and you have an operating system, and you write some code so that the sensor does the measurement. You take that, and then you take that and package it, and use that connectivity of whatever technology you have to send that up into the network.
And where does it go? Okay, so now we have sort of taken, I'm trying to figure it out. So we've taken the stuff, the breeding, we have the little gizmo that is now cellular maybe, and we have sent it somewhere, so we're sending, what are we sending? Data, and we are now thinking about different, from small kilobits to larger packages.
Yes.
And we are sending it on the network. So typically, are we now connecting then to what you highlighted Sierra has there? If you take the Sierra example, it's a machine to machine.
Yeah, so in our example, you would still, if that weather station that's out in the middle of nowhere, so it would be going over a carrier network to the radio base station.
So the radio base station part is the carrier part?
Yeah, it's still the carrier part, we don't have that. But then we would have an interconnect in the core network where that data would be routed to our network. And we would take care of that. So what it also means, so it means that in the gizmo, in the weather station, we would have our SIM card, and what that also would enable is that, say, the weather station is located at that point. You can see two carriers. There's carrier A and carrier B has coverage there. I mean that's pretty important. So our SIM would attach to either or of those networks because we have a deal with carrier A and carrier B. So because the weather, the person that's taking the weather data wants to be sure that regardless what's happened, I always want my data, right? But if he had a SIM card from carrier A and his network goes down, he wouldn't be on carrier B when that happened. He'd have to wait until carrier A has repaired his network.
Yeah, well, so the business case when we go B2B is completely different, right? Because
Yes.
it's like one of those things that cannot break down, it cannot lose. So the carrier is actually now replaceable, you know.
Yes.
So let's do them, but let's have 3 or 4 different options.
Yes.
But the data still needs to go and needs to go somewhere.
Yeah. So what our SIM does is, based on customer preferences, it will select either carrier A or B, depending, you know, be it quality of service metrics. So the carrier with the strongest signal is our first preference, then we'd use that. If it's the cheapest carrier that you have a signal with, then it would be that, for instance. So there are different, you know, metrics on that. But it would then be routed through our network, and then it would be hooked up until the data would be delivered then to a cloud of the person that's collecting the data at the weather station of his preference. So if it's IBM, if it's AWS, or...
So basically, now we have sort of taken the path from the sensor
through the network.
Through the network where we have, you know, failover on carrier level.
Yeah.
And then basically routed in from your part into whatever is the central cloud or whatever they need.
Yes. So the repository where you know where they
At
collect
the
that data.
customer's site, or
Yeah.
now we're at the customer.
Yeah. Now the customer has that, and what we do is also we do that in a secure manner, because you know. At the end of the day, you know, weather data is maybe not very sensitive, but in a lot of cases there might be sensitive data, and then you have to make sure that, you know, from A to B, that you're covered in terms of security, because that you don't want somebody listening to that data and stealing that data from you somewhere in the middle, because that's you know, that's data is our new currency. So I mean, it is valuable.
So basically, the executive summary of the introduction to IoT and wireless is like, number one, we have different types of horses for courses, fit for purpose bandwidth, depending on what type of case you have. And it has also to do not only with the size, but also if it moves around and stuff like that. And then basically we have the understanding of we have something, we need to have a reader sensor, and then we need to send it, and then the way we send it, if we want to do it B2B machine to machine, you know, a good thinking is to, you know, how do I have failovers on several carriers but still getting my data all the time?
Yes.
That's the fundamental scenario that you kind of need to think about when you do mission critical IoT. Is that a fair sort of?
Yeah, that's a high level set. But then you can make things even more complicated.
Of course you can.
So I mean, say if I'm a regional or I'm a global player in weather stations, right?
Yeah.
So I need to send these in you know, say 57 countries. I'm going to put.
Yeah.
Okay. So if I don't have, you know, in those 57 countries, there's 57 different carriers multiplied by how many there are.
So it's not only failover of 2, it's 2 times 57.
Well, I wasn't thinking about the failover, but how many negotiations do you have to get into in order to deploy that as a customer? If you now have an IoT partner like Sierra, we're not the only ones, but I mean, you have to think in those terms, because this is different.
So you flip the whole game is shifting when you go global and B2B.
Yes.
Yeah. Okay.
I mean, as a consumer, I mean, a consumer lives in one country, but if you build a product or a service, you don't know where it goes, and if it needs connectivity.
And if you have if you have long haulage, you know, or you know, you travel, or you have a Maersk, you travel across several carriers across the globe as the container moves or as the truck moves.
Yes. And you have to have deals with everybody. I mean, you can go to carrier A and they'll have roaming deals. Say, you know, even if you're in 57 countries.
They can have roaming deals.
They have roaming deals, because that's basically what it is. I mean, Sierra has, 800 roaming deals. So, I mean, that's why, you know, we can get pretty much on any network. So, I mean, that's the value to customers. So if you're building your product, your gizmo, you have a sensor, you want to get the data out, you want some sort of security in terms of it has to work all the time so that you have a failover. You want it to be delivered securely so that it's there. But you also have the case where you have deployments in many countries. You know, you don't want to go and negotiate with a number of parties. You want to go to one. Okay, I can get my hardware, I can get my connectivity there, and it will deliver my data, and I only have to speak to one person.
But I think a little bit like what I'm hearing is like when you're going into the real IoT space, like when you want to have data points on sensors like this, you're opening up a new can of worms of. That's what I'm hearing. Like, how will like you're finally done. You got your data center sorted. You think you're pretty cool, right? You've done it, and you got your WAN connections and your LAN connections for your offices. I know my shit. I know my connections, and here we go. Sensors moving around in the world potentially, right? And then it opens up a completely new package of things to consider in order to do this smartly and cost effectively.
Yes. I mean, the world is big, and this is what we forget. Where data-centric customer or companies like Facebook, Googles of the world, they exist everywhere, and you just when you log on, it's just there. But when you come into practicality in the IoT space, and when you use cellular networks, it's like, oh boy, if I'm going to be in all these places, and it's not one person I have to deal with, it's masses.
And isn't this another way? Like we look up to these tech giants, and some of them are very consumer oriented, and the consumer dimensions of an analytical model, or this consumer complexity of dealing with one phone or their sort of local smartphones, is nothing compared to when we go into the B2B industrialize. And like the real revolution is machine to machine, and now it really explodes in all the data we need to capture. But there's a huge different piece of, how does the analytical, everything is way more complex as systems. Yes. That's what I'm hearing.
Yeah, it's more complex because businesses are located in more locations, and then of course you have the security aspect. I mean, in the consumer, it's really privacy concerns, really. So it's more up to you as an individual. But I mean, the data that a company has, that's its lifeblood. I mean, in now and in the future, I mean, data is the currency. So I mean, you don't want it in somebody else's hands. So it has to be secure. You have to protect that asset. So I mean, it becomes very much more complicated. And then who do you want to rely on, and how many parties do you have to engage with in order to make?
You can make the chain work, right?
Yeah. So it is a complex world, and for you that deal, I mean, higher up in the stack, when you have the data and model it and do the smarts on it with AI and machine learning models or whatever. But I mean, the gathering the data is what I refer to as plumbing, or in this case, smart plumbing. It's something that has to be there. It has to work well. It's a prerequisite.
But let's come back to that. But okay. But here we have now the introduction to wireless and IoT 101, and let's now go into 201 and talk about 5G. So let's now, okay, so all of what we have learned now in the first 15 minutes, what is 5G and what's the difference? So what does it add to what we have now said?
Yeah, so 5G is a lot of things, but what I would describe it for is it's more of an umbrella, right? So it encompasses these low bandwidth technologies and the ultra high width.
They're both in there.
They're both in the same standard, and they're also 5G is thought a little bit more around use cases, so that you can see it encompasses things like has a whole own section for like vehicle V2X, which is vehicle to anything communication.
So you have your 5G as your umbrella sound that we know, but if you're knowledgeable. You can peel the onion and go down to 5G automotive.
Yes. So you have 5G automotive, you have 5G private networks. So you have private networks so that enterprises can build their own small private cellular networks. You have the mobile broadband, which is the consumer with the mobile phones and so forth. That still exists. And then you have the low speed technologies. I talked about NB-IoT and LTCADM that will evolve with certain enhancements. They're pretty done.
But I don't get it. So you have 5G on the top here.
Yeah.
What does it mean when I go into 5G automotive? What has happened? Have they figured out even more detailed standards, or what is that all about?
Yeah, so there are a set of standards to cater for those specific use cases. So that's what it's really done. So those things aren't needed for a mobile phone, for instance, or they're not needed for if you're connecting your sensor or
so horses for courses in 5G.
Yes. So that's why you can't. That's why the question you should ask is, okay, I want 5G. The question is still, what do you want to do?
Exactly. Okay.
So, and then you can start looking at, okay, so do I need high speed? Do I need ultra high reliability? Do I need something automotive that talks in the car and between cars and to smart cities to regulate traffic flow? Or do I need, from the use cases that are defined within the 5G standards?
But another topic, I think you told me, I think it's from you, I got this knowledge anyway. I mean, like you always say something, that there's a major difference between 4G and 5G. It's also in about the upstream and downstream and stuff like this. So there are some fundamental things that happen when we went to 5G. What are those?
Yeah, so when it comes to, I mean, data and the different Gs, I mean, the speeds have generally gone up, but if you think about the phone that you have today and the service have today, you know, it's asymmetric because it's optimized for consuming. It's for
streaming
downstream.
Coming to you to
Yes.
watch something as an example. Yeah.
Yeah. So that's a typical B2C scenario. I mean, and anybody who wants to download something from somewhere, right? Mm-hmm. But if you start moving into using cellular technology in a business to business environment, you're looking at things that might want to send a lot of data the other direction, and the networks haven't really been catering to that. So that is a bottleneck. With 5G, that is going away. So it's becoming more asymmetric, and you're increasing the speed in the uplink.
So it's not only that it's more speed, it's also the symmetry of load upstream and downstream. Yeah.
Yeah, and it's also the amount of, because.
And how big is the difference in speed? I don't know. What's the difference in speed we're talking about? Yeah. Or capacity? I don't know how you want. What's the KPIs here?
Yeah. So you're basically talking that in terms of when you talk about the uplink, you're talking 5x and more, depending on
5 times and more.
Yes. So, but it depends. Again, it depends on the spectrum used, because 5G again is in order to achieve speeds, you need spectrum. So,
and what is spectrum?
Spectrum is
bandwidth.
How should we explain this? But I mean, a radio is a bunch of waves in the air, right? And you can only fill it so much before it gets congested, right? And in order to carry more data, you have to use new frequency bands. So if you take a standard radio, I mean an FM radio, it transmits in megahertz, right? Mm-hmm. Well, if all your radio channels are from, you have to move somewhere else, and then you move into.
You move to a different spectrum. So I'm in the 800 to 900.
Yeah. But
is that what you mean?
Now you move into the gigahertz.
Okay.
Because and the higher up you move in the spectrum, there's more spectrum available. But at the same time, the higher up in the spectrum you go, you get more capacity, but the distance it travels shortens. So so
higher up in the spectrum means it's good signal, but not so far.
No. Well, the signal quality, it doesn't depend on that, but it depends how far it can go. So you have a lot of capacity, but it doesn't go very far.
And what is not very far? Are we hundreds of kilometers, or?
This is what depends. But I mean, if you take a basic, low frequency radio, you can, transmit around the world. People just put up a mast and you can do that. If you talk standard cellular sites, if we go back to Australia, that had some of the biggest cellular sites in the world. I don't know if they still have. We talked about 200 kilometers for one cell site.
For one base station.
Yeah. Now, if we talk ultra high bandwidth, where the frequency are high and you get a lot of capacity, you're talking maybe hundreds of meters that you reach.
So now we're talking about the density of base stations that is required in order to fill the cellular network with coverage.
Yes. So there are two sets of spectrums in 5G. You talk about sub-6, which is sub-6 gigahertz. So anything below 6 gigahertz is known as sub-6. And then you have that's above, you call that millimeter wave. And the millimeter wave, this is super high capacity. You're talking gigabits and gigabits and gigabits.
This is hardcore. You can send whatever you want, more or less.
Well, today. Somebody will figure out how to use that. They always do, right?
They will send GPT-3 over it.
Yeah. So and that spectrum in the millimeter space, it's symmetric. You can send just as much. You can assign it. If you want to go all up, you go all up. If you want to go all down, you can go all down. Whereas there's still some asymmetry in the sub-6.
So the sub-6 is not completely symmetric.
No.
Okay, so these are trade-offs, I guess, in order to make it work.
Yeah, and the main use case, of course, I mean, in a macro network, in a network that we typically have, I mean, it's the driving force is consumers and smartphones, and so it's optimized for that. But it's become better in the uplink, around 5 times.
And where do you think most B2B companies will live the next 10 years? What use cases are really below 6 and stuff? And is most of us below 6 or whatever you call it?
Initially, yes, because it becomes very challenging. The higher spectrum becomes challenging because the radio waves are so narrow. So they won't go through glass or walls or something.
So they also this part they need to really have good. What do you mean? They don't go through stuff as well.
No, because it's physics, right? So I mean the radio wave, you can probably stop the wave with your hand or with your body, depending on the direction you turn and so forth. So it's very sensitive signal. Where the lower signals, they penetrate the house.
Yeah.
So I mean but if you look at in an office environment, typically, because that's also the emergence with 5G, you're going to have these private networks. So companies will put up their own small base stations at their site. And then you can plan for coverage so that the machines or whatever that's going to use it are not, there's nothing in the way, so they can use that full spectrum. So, I mean, there's a number of use cases. One of the most interesting ones I've heard for millimeter wave is the car manufacturers, because the cars are no longer, a mechanical object. They're the computer on wheels, right? There's an awful lot of software and stuff in them. So when the car manufacturers have assembled, I don't know, where at the assembly point when they're finished, they have maybe 200 cars, and they have a number of systems that they want to download software to. Guess what they want? Super high capacity and super high. So if they had a private 5G network, they could flood these cars and literally within seconds have all the software downloaded.
So there's a simple use case at the end of the assembly line, but you just flood the cars and get them out, ship them out.
So I mean
that will speed up the whole.
Yeah.
That use case for the assembly line is.
Whereas today, maybe where they don't even have wireless, somebody goes with a thing and puts in a plug into every car to download. You can see this is efficiency. But
this is ultimately back to what is the problem you want to solve, and then understand that here we have a very specific flooding cars out of a manufacturing line with data, right? Load them up, boot them up.
Yeah.
Bootstrap the car. Yeah. And you could do that really smart if you knew how to use 5G in this particular context. And then you need to choose exactly what we're talking about here, type of 5G. It all connects back together of good product management.
Yes. And again, at the car manufacturing side, you might want to know where all your fire extinguishers are. Okay. Do you need gigabits of data for that? No, you probably just need a simple sensor that sends, once a day, this is where I am. Because when a fire breaks out in the factory, bing, you want something to pop up. This is where the fire extinguishers are. That's a low bandwidth application, and they have to work side by side. And there are different products that you put in and integrate and do, but they have to work as a whole.
But okay, so we have now explored a little bit like IoT into 5G. We see how the different business case, and we understand that 5G is now actually you need to peel the onion at least one level to understand what types of 5G you're talking about. That's how 5G works. Now comes the really important question. What's the point of all this? What are we going to use the data for? Or what's your view of this? All right, you talk about being the plumbing. Let's talk about, and then smart plumbing. Let's talk about that, but let's move that conversation into also what does this mean in terms of what are we going to use the data for? And so let's go, because I think this is the topic, right? We have these enablers now. But how does it all play out in the data world? What is your thoughts here?
Well, here you can see. I mean, if you build with 5G, with the speeds and the coverage and that, you're starting to end up in a situation where it's just as reliable as a cable, and in terms of latency and reliability, if you're literally as good as a cable, then you can start thinking. You can start thinking about, okay, so what does that mean? Does that mean do I need to really send all the data to the cloud? You could put. There's a trend of emerging that you probably also in the AI space of what we call edge computing. So, but I mean, if you have the reliability out at the edge, why not build a small data center at the edge? Because you have 5G and you have those capabilities, and do the processing closer to the application rather than have to send large amounts of data into the